Introduction.
This one is tangent. No, this is tangent.
Sheetal, what are you doing?
Dad, I am trying to find the tangent here. I am not sure whether I am right or wrong.
Show me. So, what according to you is a tangent?
This is tangent. Am I right, Dad?
No, you are not. This is tangent and this is normal. The tangent is a straight line which just touches the curve at a given point. The normal is a straight line which is perpendicular to the tangent.
Oh yes, I remember.
Objectives. At the end of this lesson, you will be able to learn equation of tangent, learn equation of normal, find the angle of intersection of two curves. Equation of tangent. Consider a curve y is equal to f of x and a point pxy on this curve. If tangent to the curve at pxy makes an angle theta with the positive direction of x-axis, then at the point pxy, dy by dx is equal to tan theta is equal to m is equal to gradient or slope of tangent to the curve at pxy. The equation of a tangent to a curve y is equal to f of x at a given point p x1 y1 is given by y minus y1 is equal to dy by dx at x1 y1 into x minus x1, using point slope form of equation of the straight line. Examples of equation of tangent. 1. Find the slope of the tangent to the curve y is equal to 3x raised to the power 4 minus 4x at x is equal to 4. Solution. The given curve is y is equal to 3x raised to the power 4 minus 4x. Then, the slope of the tangent to the given curve at x is equal to 4 is given by dy by dx at x is equal to 4 is equal to 12x cube minus 4 at x is equal to 4 is equal to 12 into 4 cube minus 4, which can be solved to 764. Example. Find points at which the tangent to the curve y is equal to x cube minus 3x square minus 9x plus 7 is parallel to the x-axis. Solution. The equation of the given curve is y is equal to x cube minus 3x square minus 9x plus 7. Therefore, dy by dx is equal to 3x square minus 6x minus 9. Now, the tangent is parallel to the x-axis if the slope of the tangent is 0. Therefore, 3x square minus 6x minus 9 is equal to 0. It implies that x square minus 2x minus 3 is equal to 0. It implies that x minus 3 into x plus 1 is equal to 0. It implies that x is equal to 3 or x is equal to minus 1. When x is equal to 3, y is equal to 3 cube minus 3 into 3 square minus 9 into 3 plus 7 is equal to 27 minus 27 minus 27 plus 7 is equal to minus 20. When x is equal to minus 1, y is equal to minus 1 cube minus 3 into minus 1 square minus 9 into minus 1 plus 7 is equal to minus 1 minus 3 plus 9 plus 7 is equal to 12. Hence, the points at which the tangent is parallel to the x-axis are 3, minus 20 and minus 1, 12. Example of equation of tangent 2. Find a point on the curve y is equal to x minus 2 square at which the tangent is parallel to the chord joining the points 2, 0 and 4, 4. Solution. If a tangent is parallel to the chord joining the points 2, 0 and 4, 4, then the slope of the tangent is equal to the slope of the chord. The slope of the chord is 4 minus 0 by 4 minus 2 is equal to 4 by 2 is equal to 2. Now, the slope of the tangent to the given curve at a point xy is given by dy by dx is equal to 2 into x minus 2. Since the slope of the tangent is equal to slope of the chord, we have 2 into x minus 2 is equal to 2. It implies that x minus 2 is equal to 1. It implies that x is equal to 3. When x is equal to 3, y is equal to 3 minus 2 square is equal to 1. Hence, the required point is 3, 1. Example of equation of tangent 3. Find the equation of the tangent line to the curve y is equal to x square minus 2x plus 7, which is perpendicular to the line 5y minus 15x is equal to 13. Solution. The equation of the line is 5y minus 15x is equal to 13. 5y minus 15x is equal to 13. It implies that y is equal to 3x plus 13 by 5. This is of the form y is equal to mx plus c. Therefore, slope of the line is 3. If a tangent is perpendicular to the line 5y minus 15x is equal to 13, then the slope of the tangent is minus 1 by slope of the line is equal to minus 1 by 3. It implies that 2x minus 2 is equal to minus 1 by 3, which can be solved, and we get x is equal to 5 by 6. It implies that y is equal to 25 by 36 minus 10 by 6 plus 7, which can be solved, and we get 217 by 36. Thus, the equation of the tangent passing through 5 by 6, 217 by 36 is given by y minus 217 by 36 is equal to minus 1 by 3 into x minus 5 by 6, which can be solved, and we get 36y plus 12x minus 227 is equal to 0. Hence, the equation of the tangent line to the given curve, which is perpendicular to line 5y minus 15x is equal to 13, is 36y plus 12x minus 227 is equal to 0. Addition information about tangents. Look at this figure. Here we can see that if dy by dx is greater than 0, the tangent makes an acute angle with the x-axis. If dy by dx is less than 0, the tangent makes an obtuse angle with the x-axis. If dy by dx is equal to 0, the tangent is parallel to x-axis. If the tangent is perpendicular to x-axis, then dy by dx is equal to infinite, that is, dx by dy is equal to 0. If the tangent is equally inclined to the axis, then dy by dx is equal to tan 45 degree or tan 135 degree is equal to plus minus 1. Equation of normal. The normal to a curve at a point Px1y1 is a line perpendicular to the tangent at P and passing through P. Slope of the normal is equal to minus 1 by slope of tangent is equal to minus 1 by dy by dx at point px1y1 is equal to minus dx by dy at point px1y1. The equation of normal to curve y is equal to f of x at a given point px1y1 is given by y minus y1 is equal to minus 1 by dy by dx at point x1 y1 into x minus x1. Since the normal to the curve at the point px1 y1 is a line perpendicular to the tangent at the point px1 y1 and passing through it, therefore slope of normal at px1 y1 is equal to minus 1 by slope of tangent at px1 y1. Example 1. Find the slope of the normal to the curve x is equal to a cos cube theta, y is equal to a sin cube theta at theta is equal to pi by 4. Solution. It is given that x is equal to a cos cube theta and y is equal to a sin cube theta. Therefore, dx by d theta is equal to 3a cos square theta into minus sin theta is equal to minus 3a cos square theta into sin theta. dy by d theta is equal to 3a sin square theta into cos theta. Therefore, dy by dx is equal to dy by d theta upon dx by d theta is equal to 3a sin square theta into cos theta by minus 3a cos square theta into sin theta is equal to minus sin theta by cos theta is equal to minus tan theta. Therefore, the slope of the tangent at theta is equal to pi by 4 is given by dy by dx at theta is equal to pi by 4 is equal to minus tan theta at theta is equal to pi by 4 is equal to minus tan pi by 4 is equal to minus 1. Hence, the slope of the normal at theta is equal to pi by 4 is given by 1 by slope of tangent at theta is equal to pi by 4 is equal to minus 1 by minus 1 is equal to 1. Example 2. Find the equation of the normal at the point am square am cube for the curve ay square is equal to x cube. Solution. The equation of the given curve is ay square is equal to x cube. On differentiating with respect to x, we get 2ay into dy by dx is equal to 3x square. It implies that dy by dx is equal to 3x square by 2ay. The slope of a tangent to the curve at x0, y0 is dy by dx at x0, y0. It implies that the slope of the tangent to the given curve at am square am cube is dy by dx at am square am cube is equal to 3 into square of am square by 2a into am cube is equal to 3m by 2. Therefore, slope of normal at am square am cube is equal to minus 1 by slope of the tangent at am square am cube is equal to minus 2 by 3m. Hence, the equation of the normal at am square am cube is given by y minus am cube is equal to minus 2 by 3m into x minus am square. It implies that 3my minus 3am raised to the power 4 is equal to minus 2x plus 2am square. It implies that 2x plus 3my minus am square into 2 plus 3m square is equal to 0. angle of intersection of two curves. Let y is equal to f of x and y is equal to g of x be two curves intersecting at a point p x1 y1. Then, the angle of intersection of these two curves is defined as the angle between the tangents of the two curves at their point of intersection. If theta is the required angle of intersection, then theta is equal to plus minus theta 1 minus theta 2, where theta 1 and theta 2 are the inclinations of tangents to the curves y is equal to f of x and y is equal to g of x respectively at the point P. Method to find the angle of intersection. Find f dash x and g dash x. If f dash x into g dash x is equal to minus 1, then the two curves are said to cut each other orthogonally wherever they cut. If the product is not minus 1, solve the equation of the two curves to get their point of intersection. If alpha beta be their point of intersection, then find f dash alpha and g dash alpha. Let m1 is equal to f dash alpha and m2 is equal to g dash alpha. If theta is the angle between the tangents, then tan theta is equal to plus minus m1 minus m2 by 1 plus m1 m2 is equal to plus minus f dash alpha minus g dash alpha by 1 plus f dash alpha into g dash alpha. Repeat this process for other points of intersection. Example. Prove that the curves x is equal to y square and xy is equal to k cut at right angles if 8k square is equal to 1. Solution. The equations of the given curves are given as x is equal to y square and xy is equal to k. Putting x is equal to y square in xy is equal to k, we get y cube is equal to k. It implies y is equal to k raised to the power 1 by 3. Therefore, x is equal to k raised to the power 2 by 3. Thus, the point of intersection of the given curves is k raised to the power 2 by 3, k raised to the power 1 by 3. Differentiating x is equal to y square with respect to x, we have 1 is equal to 2y into dy by dx. It implies dy by dx is equal to 1 by 2y. Therefore, the slope of the tangent to the curve x is equal to y square at k raised to the power 2 by 3, k raised to the power 1 by 3 is dy by dx at k raised to the power 2 by 3, k raised to the power 1 by 3 is equal to 1 by 2 into k raised to the power 1 by 3. On differentiating xy is equal to k with respect to x, we have x into dy by dx plus y is equal to 0. It implies that dy by dx is equal to minus y by x. Therefore, slope of the tangent to the curve xy is equal to k at k raised to the power 2 by 3, k raised to the power 1 by 3 is given by dy by dx at k raised to the power 2 by 3, k raised to the power 1 by 3 is equal to minus y by x at k raised to the power 2 by 3, k raised to the power 1 by 3 is equal to minus k raised to the power 1 by 3 by k raised to the power 2 by 3 is equal to minus 1 by k raised to the power 1 by 3. We know that two curves intersect at right angles if the tangents to the curves at the point of intersection, that is at k raised to the power 2 by 3, k raised to the power 1 by 3 are perpendicular to each other. This implies that we should have the product of the tangents as minus 1. Thus, the given two curves cut at right angles if the product of the slopes of their respective tangents at k raised to the power 2 by 3, k raised to the power 1 by 3 is minus 1. That is, 1 by 2 into k raised to the power 1 by 3 into minus 1 by k raised to the power 1 by 3 is equal to minus 1. On solving, we get 8k square is equal to 1. Hence, the given two curves cut at right angles if 8k square is equal to 1. Did you know? Let the tangent and normal at the point px, y on the curve meet the axis of x at the points t and n, respectively. Let m be the foot of the ordinate at P. Then, length of the tangent is equal to pt is equal to modulus of y cosec theta is equal to modulus of y into square root of 1 plus cot square theta is equal to modulus of y into square root of 1 plus dy by dx square divided by dy by dx is equal to modulus of y by dy by dx into square root of 1 plus dy by dx square. Length of the normal is equal to Pn is equal to modulus of y sec theta is equal to modulus of y into square root of 1 plus tan square theta is equal to modulus of y into square root of 1 plus dy by dx square. Subtangent is equal to Tm is equal to modulus of y into cot theta is equal to modulus of y upon dy by dx. Subnormal is equal to Mn is equal to modulus of y tan theta is equal to modulus of y into dy by dx. Length of perpendicular from origin 0, 0 to the tangent drawn at point P x1 y1 to the curve y is equal to f of x is P is equal to modulus of y1 minus x1 into dy by dx at x1 y1 divided by square root of 1 plus dy by dx square. Length of the intercepts made by the tangent on the axis. Equation of tangent at any point x1 y1 to the curve y is equal to f of x is y minus y1 is equal to dy by dx at x1 y1 into x minus x1. Then x-intercept is equal to x1 minus y1 by dy by dx at x1 y1 and y-intercept is equal to y1 minus x1 into dy by dx at x1 y1. Summary. Let us summarize what we have learned. The equation of the tangent at x0 y0 to the curve y is equal to f of x is given by y minus y0 is equal to dy by dx at x0 y0 into x minus x0. If dy by dx does not exist at the point x0 y0, then the tangent at this point is parallel to the y-axis and its equation is x is equal to x0. If tangent to a curve y is equal to f of x at x is equal to x0 is parallel to the x-axis, then dy by dx at x is equal to x0 is equal to 0. Equation of the normal to the curve y is equal to f of x at a point x0 y0 is given by y minus y0 is equal to minus 1 by dy by dx at x0 y0 into x minus x0. If dy by dx at the point x0 y0 is 0, then equation of the normal is x is equal to x0. If dy by dx at the point x0 y0 does not exist, then the normal is parallel to the x-axis and its equation is y is equal to y0.